Hello and welcome to the next video in our applications course focusing on scale factor and the relationship to surface area and volume. Now I'm a little disappointed that I can't have my picture on the screen, but that's because this slideshow's all over the place and would just get in the way. So let's get started. Scale factor. How to find scale factor? When a figure is dilated, its size is changed by multiplying the length of each side by a scale factor. All angles remain the same, so the new shape or image is similar to the original. The scale factor can be found by dividing the new side length by the original side length. So the new over, where's my mouse gone? There we go, new over old. When going from a small shape to a larger shape, the scale factor is greater than 1, so it's going to be an enlargement, which means that you have the bigger shape divided by the little shape. When going from a large shape to a small shape, we're getting less, so it's reduction, so we have a little shape over the big one, which means you're going to get a fraction, whereas this one you're going to get a number greater than 1, so it enlarges, etc. Moving on. Determining the scale factor. Now this slideshow has already skipped ahead, but it goes through quite nicely how to find the scale factor. Basically, these two triangles are similar because the ratio of corresponding sides are the same. To find the scale factor, you can determine what factor was multiplied by a side length to create the corresponding side length. So corresponding sides means that the sides that match each other. So we've got our 6 centimeters is our orange line. That matches our 24 centimeters. And the 2 matches the 8 and the 5 matches the 20. Well, wow, it does it for me. And if you look closely at it, our scale factor has been worked out already by going 20 divided by 5, which gives us 4. And if you notice, 6 times 4 is 24. 2 times 4 is 8. And 5 times 4 is 20, which we already worked out. So the scale factor from the smaller triangle to the larger triangle is 4. The scale drawing can be written as a ratio of 1 centimeter to 4 centimeters, though when you're writing ratios you probably shouldn't include the units, so it should just be 1 to 4. Determining the scale factor. We're still doing this? Okay. Just having a go now. We find the matching sides. This time we're going from a bigger shape to a smaller shape. So we go the new shapes sides, so the 6 matches the 12, so we're going 6 divided by 12, which is 0.5 or a half. So let's just draw in our matching sides. So everything's been times by a half on this one, which is, we've made it smaller, which is kind of cool. Right, these two triangles are similar because the ratio of corresponding sides are the same. To find the scale factor, you do blah blah blah. We've done that already. So we can say that the scale factor from the large triangle to the smaller triangle is 0.5. How exciting. And we can write it as a ratio of 1 to 0.5, or you could write it as 2 to 1, which is probably the better way to do it. Okay, scale factor and surface area. So now we're going to look at how scale factor can relate to surface area and help you with some calculations. Right, the rule to find the area of the second shape, we multiply the area of the first. Oh, I've just tongue-tied myself. The rule to find the area of the second shape, multiply the area of the first shape times the scale factor squared. So what's that saying is, we find the area of, we know the scale factor is 2 by working it out with our matching sides. Bit of magic there, okay. So the area of the small shape is length times width, so we've got 1.75 times 2.8, which gives us our 4.9 centimeters squared. So if we go our length times width times our scale factor squared, we're going 1.75 times 2.8 times 2 to the power of 2, because our scale factor was 2, remember? And that equals 19.6. So let's check this. The area of the larger one is length times width, so now we're going to go 5.6 times 3.5, which gives us 19.6 centimeters squared, which is the same. Amazing how that works. The reason this works is because the area is increased. The reason this works is because the area is increased by length and width. If both dimensions are increased, you are squaring. So if we look at this, The area of the front of the smaller prism is 3 times 5. The area of the front of the larger prism is 6 times 10, which if we look at this, we're going 3 times 2 plus times by 5 times 2, because we've increased our sides by the scale factor of 2, because our scale factor is 2 in this case as well. Oh, I have to click something. And remember, you can multiply in any order, so if we rearrange this, we can go 3 times 5, which is our area of the smaller prism, times by 2 times 2, which is 2 squared, which then gets us to 15 times 2 squared. So that's how we get to the whole timesing by the scale factor squared. So the area of the front face of the larger prism is 2 to the power of 2 times, or 4 times, the area of the front face of the smaller prism. This is true for all corresponding faces. Thus, this is also true for the entire surface area of the prisms. So, the surface area of similar figures. Surface area of a three-dimensional figure A is equal to the surface area of a similar figure B times the square of the scale factor of figure A. So if we've got the surface area of figure A, the surface area of figure B times the scale factor of figure A squared. Yeah. Finding the surface area of find the surface area of a box that is 35 centimeters squared. What is the surface area of the larger box if the of a larger similarly shaped box that has a scale factor of 7? So basically what we're going to look at is we're going to take our 35 centimeters squared and we're going to times it by our scale factor squared. So we've got 3.5 times, that little dot means times by the way, times by 7 squared. We're going to evaluate the power, so our surface area is going to be 35 times 49, which if we do the multiplication we get 1,715. So the surface area of the larger box is 1,715 centimeters squared. Okay, let's have a look at another example. This time we're shrinking it. So our scale factor is a half. So we're going to go taking the surface area of the original box, which is 1,300, times by a half squared, because that's our scale factor, and we are squaring it because it's surface area. Evaluate the power. So if you square a quarter, if you square a half, you should get a quarter, just using your index laws. Right, so if we do the multiplying of that, we get 325. So the surface area of the smaller box is 325 meters squared. Simples. Okay, now let's look at scale factor and volume. It's basically the same concept, except the volume is cubed. So we're going to scale, the rule is to multiply the volume of the known by the scale factor cubed, or to the power of 3. So remembering you are increasing the length, width and height, so now we've got an extra side that we are, or an extra length, extra distance that we are changing, we have to cube it, or thus cubing. So if we've got the scale factor is 3 because all the sides were tripled, what was the volume of the larger prism? Hint, volume of the small times the scale factor 3. So basically we're going to find the volume of our first prism by going 3 times 5 times 10, which is 150, because 10 times 3 is 30, 30 times 5 is 150. Now we're going to times that by the scale factor to the power of 3. So our scale factor is 3, so we're going times by 3 squared, cubed, it's cubed, which is 150 times by 27. Plug that into your calculator and you should get 40,050 centimeters cubed. So basically we're doing the same thing as the surface area, except now it's volume, we're cubing instead of squaring. So let's look at this one. What is the scale factor? Well, let's work that out. We're going to pick our matching sides, which is the 5 and the 10. So we're going the new one divided by the old one. 5 divided by 10 is 0.5. So our scale factor is a half. What is the volume of the smaller triangular prism? Let's work that out, finding that should have a right angle there just to make it work. So we're going 10 times 5 divided by 2, or half the base times the height. So that gives us 750, because we're going half the base, which is 5, times by 5, and then we're timesing by the length of the prism, gives us 750. Now we're timesing that by a half cubed, which, if you work it out, is 1 over 8. And that should give you 93.75 centimeters cubed. So we've now worked out the volume of the smaller object just by using our scale factor knowledge. Okay, that concludes our video for today. In class we will be doing these exercises, so have a read of them if you want, and see you next time.